Okay, I wanted to give an example of how to graph an ellipse. And basically, I want you to show the x and y intercepts and the foci. So the first thing you do is you need to identify the a, the b, and the c. And we have two general equations. And when you're dealing with the ellipse, the a squared is the biggest number. That's the easiest way to determine which type of ellipse we have. And here, 16 is bigger than 9, so 16 is our a squared. So we have this type here, or the first type on your note sheet. So with that in mind, we can go a squared equals 16, b squared equals 9. So this means that a equals 4 and b equals 3. And then on your note sheet there's an equation that helps you find the c, which we need when we identify the foci. So the equation is c squared equals a squared minus b squared. So in this case, c squared equals 16 minus 9. And c squared equals 5, so c equals the square root of 5. So according to this, the foci on this is minus c0 and c0. So root 5 minus root 5, 0, and root 5, 0. So now we know what that point is. And it's good to use your calculator to get a decimal value of that, just so that when you're graphing on your coordinate system, you have an accurate idea of what that is. So that's about 2.2. So I usually write that in there just so that I know. All right, so how do I go about sketching this? Well, put our grid here, okay, and then on the x-axis, we count a in both directions. That's our major axis. So I count 1, 2, 3, 4. Put a dot. 1, 2, 3, 4 in the minus direction. Put a dot. So our ellipse is going to go through those 2 points. But where else does it go through? On the y-axis, I'm going to count. What do you think? Do you know? I hope you said 3. Yeah, I'm going to count 3 there. And 3 here. And now I can sketch in my ellipse, and I need to label the foci. So root 5 is 2.2, so about there. We'll call this one F1, and minus 2.2, we'll call this one F2. Now the interesting thing, once you have that point, if you were to think about the definition of what an ellipse is, I'm going to just draw random lines from the 2 foci points to any point on the ellipse. And these 2 amounts are constant for the ellipse. In other words, if I put another point there and drew lines to both of the foci points, the sum of those 2 lines is constant, okay, for any point around that ellipse. And basically, that's what the definition of an ellipse is. The set of all points P in a plane such that the sum of the distances from P to the 2 fixed points, F1 and F2, is given by a constant. And it's the constant of that sum. So anyway, these are pretty easy to graph. Let me do one more. So let me erase this, and I'm going to do one more for you. All right? So that one was largest around the x-axis. Let's try another one. How about this one? X squared over 9 plus y squared over 25 equals 1. This one's going to be larger around the y-axis. Now, which number is the a squared? Is it the 9 or the 25? Is it always the first number? I think not. This time it's the 25, right? So I'm using this sample here where the a squared is second. So again, A squared is 25, so A is 5. B squared is 9, so B is 3. And how do I find C? Well, C squared equals A squared minus B squared, A squared minus B squared, which is 25 minus 9, right? So what's 25 minus 9? So C squared equals, you know what that is? Give me a second. Hopefully you came out with 16. So C equals 4. Oh, this one came out to be a nice number. So again, if I were to sketch this, why did I need C? Do you remember? Right, focal radii, and they are, in this case, 0 minus C, so 0 minus 4, and 0, 4. So, how do I go about graphing it? What do I count on the x-axis? Do I count 9? No, 3, okay. And 3. All right, what do I count on the y-axis? Do you remember? 25? No, 5. 1, 2, 3, 4, 5. All right, there's our 5. 1, 2, 3, 4, 5. There's about 5 right there. Now I'm going to sketch this ellipse. It's rounded now. There we go. That's a little bit better. And then let's put in the foci. 1, 2, 3, 4 right there. F1. 1, 2, 3, 4 right there. F2. And there you have another example of how to sketch an ellipse. So hopefully this will help you do your homework. I'm going to show one more part of an example. Okay, sometimes when you're given the equation, it doesn't look quite so nice. For example, what if I had 4x squared plus 3y squared equals 48? That doesn't look like the proper ellipse equation. Notice both of those are equal to 1. Well, this one's equal to 48. What gives? Divide everything by 48. We can make it a 1. No big deal. We know how to do a little basic algebra, right? So, now we're going to reduce everything. That side was easier. All right, 4 into 48, 12. So, x squared over 12 plus y squared over 16 equals 1. So, which one is the a squared? The biggest number. So, a squared is 16, a is 4. B squared is 12. Now, when you're doing b squared equals to 12, if it doesn't come out to a nice square root, just rationalize it a little bit. So 12 is the same thing as 3 times 4. So how about 2 root 3 is what I'd like you to use for the answer. But again, when you're graphing it, you need the decimal. So use your calculator to get the decimal. And one other tricky example I wanted to show you. And let me put that up, and then you should be good for your homework. Suppose you have x squared plus 16y squared equals 1. Well, it doesn't look like that yet. We can divide everything by 1. So I could do x squared over 1 plus 16y squared over 1 equals 1. And it almost matches the equations. The problem is this 16. And you can't have a number in front of the squared terms on the general equation of the ellipse when you're trying to do a quick graph. So the way to get around that is x squared over 1. This is 16 times y squared. Well, it could be also written as y squared over 1/16 equals 1. And I can prove that because y squared over 1/16 really means y squared divided by 1/16, which really means y squared times 16 over 1, which is 16y squared. So, y squared over 1/16 is a different way to represent 16y squared. So whenever there's a number in front with the x squared or the y squared term, remember you have to have coefficients ones there if you want to graph it properly, right? Because now I have my a squared and my b squared. This one's kind of a bizarre graph because on the x-axis I count over 1, but on the y-axis I count up 1/16. So you might want to expand how you name the coordinates on the graph. But all the other stuff works out the same, so good luck on the homework.